Okay, let's talk about class diagrams. These are the diagrams that most people think of when they think of UML. They describe the classes in your code and the relationships between them. Here's a simple class diagram for an order processing system. Let's talk about the classes first, and then we'll discuss the relationships between them. Classes have names, attributes, and operations. At the very least, classes will have a name. But for a class with all three elements, let's look at the order class. The class has attributes date received, is prepaid, number, and price. The attribute date received has type date. The 0 to 1 is called a multiplicity. It answers the question, how many? For example, in the case of date received, it indicates that there can either be 0 or 1 of these. Another way of saying this is that putting a date on an order is optional. But what exactly does that mean in terms of implementation? How would you implement 0 or 1 date received attributes? Please pause the video and tell me how you might implement the date received attribute in a Java class named order. Okay, the 0 to 1 on the date received attribute means that putting the date on the order is optional. I'm guessing that most Java programmers would implement this by creating a date received field of type date and allowing it to be null. Null meaning that the order does not have a date. Whether or not you allow the date to be null, you're probably going to provide a method in the order class that checks if there is a date. For example, has date received. If you're using Java 8, you can take advantage of the option type and create a field of type option that holds a date. As Fowler says, the point of a UML diagram is not to tell you exactly how you should implement things, but to give you enough information so you can look at the diagram and have a general idea of how you're going to implement things. Okay, let's get back to the class diagram. We were looking at the order class. In addition to the date received attribute, the order class also has a Boolean attribute is prepaid, an attribute named number that's a string, and an attribute named price that has type money. You may think the number attribute should have type integer. That's a design decision you're going to have to make when you create your design model. Other than the date received attribute that we just talked about, none of the three remaining attributes is optional. There's exactly one occurrence of each. This is stated explicitly with the attributes is prepaid and number, but if you don't see these multiplicities, you can usually assume that there's exactly one of something. In addition to the attributes in this order class, we also see the operations dispatch and close. Okay, that's it for the structure of the classes. Now let's look at the relationships between the classes. These are denoted by the arrows in a class diagram. The most common relationship is association, like the association you see between order and customer. The association is a has-a relationship in the direction of the arrow. For example, here the association arrow is telling us that an order object has a customer object. Furthermore, if you look at the multiplicity on the right side of the arrow, it tells us that an order object has exactly one customer object associated with it. The asterisk on the left side of the arrow stands for potentially many. This tells us that potentially many different orders can be associated with the same customer, which should make perfect sense because a single customer can place an order multiple times. Okay, before we look at other relationships, we've got another pause and think coming up. I said that an association arrow denotes a has-a relationship between objects. Question: how would you implement this has a relationship between order and customer in Java? Please pause the video and try to figure out how you would do this. Okay, ready? The answer is that you would implement this has a relationship just like you would implement any has a relationship in Java. You would have a field, instance variable, in your order class that was of type customer. Now, you might think, wait a minute, isn't that how we would typically implement attributes? Didn't we just talk about an example with the date received attribute where we implemented it as a field? The answer is yes. That's how we implement attributes. So your next question should be, then why wouldn't we make customer an attribute of order instead of showing the whole class? And a reasonable answer might be, well, maybe we're interested in seeing what the customer class has in it. And your next question might be, okay, well, maybe we should show the whole date class instead of making date received an attribute. And the answer would be, well, maybe we're not interested in seeing what's in the date class. Or maybe the date class is just too simplistic to represent in our diagram, and it would just clutter things up unnecessarily. Okay, here's an important slide. This slide shows two ways to represent object properties in a UML class diagram. You can loosely think of properties as the fields of an object. If you want a more thorough explanation, read Fowler. One way to represent properties is with attributes, and another way to represent properties is by association arrows. So these two diagrams essentially say the same thing. The reason that you would want to use one representation over another is a matter of emphasis. You're going to use associations for more significant classes like customers or orders, and you're going to use attributes for small objects like dates or booleans. Another way of thinking about this is, what classes do you want to define in your analysis model? Those are the classes you should put in your UML class diagram, and if they're in your UML class diagram, you're going to use associations to represent them as properties. Let's go back to our class diagram, and let's look at the association between order and order line. Recall that an asterisk multiplicity means potentially many. So this association says that an order has potentially many order line objects. If an order can have any number of order line objects, how are we going to implement that in Java? I'm not going to ask you to pause the video for this one, but if I gave you 10 seconds, could you tell me how you would implement an order class if it could have an arbitrary number of order lines? 10 seconds starting from now. Okay, this one shouldn't be that difficult. You simply have a field in order that is a collection of order lines. Notice that word ordered in curly braces. This is a constraint, and it means that the collection of order lines must be held in a particular order, presumably the order that they were added to the collection. Therefore, you're going to need a collection that supports ordering, and the natural one to use here is list. Notice also the role name line items. This is simply going to be the name of your field. So in Java, you would have a field in the class order line that was named line items, and the field would have type list of order line. Okay, there's one last relationship in this diagram that I want to talk about, and that's the generalization arrow. You can see this arrow between corporate customer and customer, for example. In fact, according to the diagram, both corporate customer and personal customer are generalizations of customer. Here again, I'm not going to ask you to pause the video, but if I gave you 10 seconds, can you tell me how you would implement generalization in Java? 10 seconds starting now. Okay, this one should not be difficult either. Generalization implies an is-a relationship. Remember, we already talked about how to represent a has-a relationship through an association arrow. An is-a relationship means inheritance, and you implement inheritance in Java with the keyword extends. So in your corporate customer class, you would write corporate customer extends customer. Likewise with personal customer. Finally, the last thing we need to talk about in this diagram is constraints. Constraints are represented inside of curly braces. We've already seen the constraint saying that the collection of order lines must be ordered. We can see two other constraints in this diagram. The first concerns personal customer. It says that get credit rating equals poor. The second is a more involved constraint attached to the order class. It reads, if order.customer.getCreditRating is poor, then order.isPrepaid must be true. Now, this time I am going to ask you to pause the video and tell me in plain language what these two constraints taken together tell us about corporate customers. Okay, this is a little tricky. The constraint on order says, if the customer's credit rating is poor, then the order must be prepaid. The constraint on personal customer says, the credit rating for the personal customer must always have a value of poor. Put these constraints together and you get personal customers must always prepay. Now, what does this say about corporate customers? Well, according to the diagram, there are only two kinds of customers, corporate customers and personal customers. And since personal customers must always prepay, we can say with confidence that if a customer is allowed to buy on credit, that customer must be a corporate customer. Or we can say corporate customers are the only kind of customers that are allowed to buy on credit. But be careful, we cannot say that all corporate customers are allowed to buy on credit, because there's not a constraint that says every corporate customer will have good credit. Okay, that concludes our discussion about class diagrams. We'll now turn to another type of UML diagram, the sequence diagram.